Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll introduce another method for the native Unreal Engine step-by-step transmission. And now there is a method that is a very bad design. Let me explain why this design. I don't know why they designed it this way, but personally, I think this design is very bad. Maybe there are some historical reasons for it. We can't really say much about that. Okay, we need to save this step-by-step transmission for everyone. Come here. Let's give it an overband save. Overband save. Let's keep it simple. We don't need this. For example, right now, we are currently counting in the scene. All players' names and health values. Actually, we should write it like this. We should do it this way. We can write this save like this. Pure info. Then it is pure info. It is a host, right? Then it is a host. Then there is an object inside. So the first name of this object is lamb, right? Lamb. For example, let's give it a name called Gang. Then his health value, we give a float value. This float value, we call it health. We give him 11.5. Okay, 11.5. Then the second player might be Xiaobai, right? So we need to stick it like this. XD, right? Then we give it. Its health is 12.5. So such a connection is acceptable. It is very good. Very easy to use. So let's change the name. Then click once. Then close this. And this one we call worry bad. It's not a very bad design. So what kind of design will this worry bad design turn into? It will turn into a design like this. It will give you a review. It is also called review. It is called player Xiao Gang. Then its value is this. For example, 5.6. Then next play. Its value is 3.7. Then we give another player. Its health value is 15.6. Okay, so for this design, I ask you, it is different in different scenarios. It is not the same. Its K value, right? It might have DD, there's CC, there is FF, GG. It has a lot more. You simply don't know how many pairs this K value actually has. So this kind of saving, can we parse it? We can also parse it. This is completely fine, but this kind of parsing we can only use out. That is, using the parsing we learned in these two lessons. The parsing method we learn in the next lesson, you won't be able to use it because this thing is not fixed. It might be a GUID here, right? So let's simulate the situation for everyone. This is a very bad design. If you have the authority in the project team for this kind of design, you better nip it in the bud. Because this design is very bad. Let's rewrite it. Normal, non-specialized designs don't need to be written this way, because the front part is the same. It is a number. There are many objects under the number. We are bad class. Okay, so how do we do it? First, we need to serialize such a class. Right, let's prepare one first. We are bad. Let's wait for a txt file. Then the same. So let's prepare a write stream. We just copy this write stream over. Because I usually don't write this code much. I basically don't write it much anymore. I usually find one each time. Copy it from a project I've written before, because this has been used many times. Then here, we definitely need to give it red object end and red object stars. Right, then inside this suite. Now let's go simulate this. So how do we simulate it? It's actually very simple. We do a negative loop. Let's assume this is a 4-player scenario. So we only have 4 objects. This works no matter how many players we have. This parsing method can handle any number of players. But let's assume 4 for now, because the key point is to simulate this unordered kids. Then we need to prepare a GUID. We'll use it as the player's name, like this. Only then can we say that this kid is unordered. Okay, that is, it is not fixed. Then fstream clear lem. Okay, so after we have this player lem, now we can start writing. So how do we write this? We write it like this. Then we pass in this player lem Okay, then let's give it an I here. It doesn't matter. We don't really care about this health value. Okay, this player lamb we are passing is this one. Okay, so in this way, we actually have this receiver. So when we read it, how do we read it? Then they will be generated. We just saw that acceptance, and its GUID each time is actually different. So to ensure this difference, if it is different, we will save it for everyone. Where is the code? We pasted and saved. This is hard to find. Let's find it this way. There is one. We'll save it locally. Here. Let's save it here. For this spawning, it goes here for half of the spawning. After saving, how do we read it now? We have a half available here. Then it equals what we have prepared. We don't need to load it from the disk again. And the writing here is quite special. Similarly, we create a write stream. We give it a bank. We just use a bank like this. Then we create this read stream. This is the read stream. A slip of the tongue here. This place writer. Put it here. Put this object here. Then this side must have succeeded in the virtual real conversion. Then after the virtual real conversion succeeds on this side, we will write this code like this. We will directly do it this way. We directly get these values from this U object. You can see. So what is this values? It is actually a key value pair format. The first is f-string. The second does the actual value. Then when we need to use it, then our ship network transmission in the military. It is this beacon. He defined this interface and this data like this. So when we use it, we definitely cannot use it this way. When we use it, we usually write it like this. You can certainly use a tab. Write it like this with tmap, and then this f-stream float, right? You can do it this way, no problem at all. That is like this. You use the same writing style as him, like enforce. No problem, but you cannot directly parse it into this thing. You can also directly define a struct. For example, define a struct. It's called player enforce. Then we duplicate it inside. That is also acceptable. This approach is fine. But for this player enforce, we don't have this yet. We'll use this struct. And here, we'll add this information in. We add. And obviously, this is its key value, right? When we actually parse it, we can take its value. Then we add it. Add number. Okay, like this. Good. Now let's execute this code. Let's take a look at it. A equals 1. Let's set a breakpoint. Like this, we've also parsed it out. And actually, let's first let it generate properly. For this generation, let's first check the result. We generated 4. We'll write this separately. Actually, the issues are manageable. The troublesome thing is him. Usually he doesn't give you such a saving separately. He wraps it in many layers, then suddenly throws something like this at you. It's extremely troublesome to deal with. Right. Look, how do you get Y from this? You can't even drink it. Right. This thing is different every time. This kind of design is really, really bad. Then here we parse it back. We can look at our map. Our map has this value. We parse it back. Right, 0123. Right, then we can use it in our project. This part is absorbed. You can ignore it. Okay, that concludes this lesson for everyone. It is a very bad design. Everyone should try to avoid it. Thank you all.